The last thing I can do with my parent functions is make predictions using the parent functions when I'm given a set of data. So here I have a table for a pendulum swing, and we want to figure out the time that it's going to take the pendulum to make one complete swing back and forth when it's dependent on the length of the string. So the first thing it asks us to do here in A is to graph the relationship from string length to time. So I'll have the length on my x-axis and the time on my y-axis. We can scale each one of our axes by 1. So now I can plot my points. So my first point is at 2 and 2.8. So the length would be at 2. Now 2.8 is almost 3, so I'm going to put a dot just below 3. Then I have 4 and 4.0, so that's our perfect point. Then I have 6 and 4.9, so that's almost 5. Then I have 8 and 5.7, so it's going to be just over 5.5. Then I have 10 and 6.3, so it's just above the 6. Okay, and if I have a point at 0 to represent my string length and time of no length and no time, that'll complete my graph. So if I connect all of these points, I can now predict which kind of parent function I have. So in part B, it asks us to describe which parent function best describes this function. So to me, this looks like it should be our square root function. It has that claw-like shape. It starts and then it goes off in an arcing fashion. In part C, we want to use our graph to estimate the string length of the pendulum that takes 4.5 seconds to make one complete swing. Since it gave us a time, I'm going to go over to my y-axis where I have time. I'm going to figure out where 4.5 is, so between 4 and 5. I'm going to just carry my pencil over until I hit my graph, and then I'm going to drop my pencil down. Now yours may be slightly different. We are predicting, so nothing is perfect. So when I do mine, it looks like it drops down between 5 and 6. So as far as the length is concerned, it looks like it's going to be about 5.5 meters in length.